Internet, welcome back. It has been one hell of a week, but the show must go on. So, we are on level 23, Dex 2, and I want to give a huge shout out. First things first is specifically to SuperJackdrummer. So, I'm not sure who this is, but they've helped me tremendously. Reason being is that we went back and forth over and over, having him assist me in figuring out specifically why I failed with Dex. As you can see, the check mark is there, so I achieved what I needed to achieve, and that's actually a huge deal. And I'll show you even in the comments here how much patience this SuperJackdrummer person had. We went back and forth, and he could see just how much I struggled to understand his or her explanation, and they actually eventually just went ahead and created a video and screen shared every single step that they took to teach me how to actually solve Dex. And that's part of the reason why I love the internet so much, is because there's so many different people around the world that are willing to help each other with such a small niche problem. So yeah, that's super exciting, super rewarding to know that there are people out there in the community, both watching and willing to support me and others on their Web3 journey. So with that being stated, let's get this party started. So Dex 2 is similar to Dex. So interestingly enough, Dex 2 is identical to Dex, the old version of Dex. So if you watched my first Dex video, you'll see me explain basically that Dex went through iterations of them actually updating the challenge and altering the code for Dex. And for Dex 2, they've actually reverted back to the older version. So the initial post that I talked you through for this post here, it actually gives you the solution for Dex 2. It almost gives you the entire solution. You have to do a little bit more, but this basically gives you exactly what you need to do, which I thought was interesting how they would basically apply Dex 2 as the older version of the code, but it's just another way to learn how to hack a Dex, specifically ones that don't necessarily implement the ERC20 specs correctly. So with Dex 2, the challenge basically states that in this level, we ask you to break Dex 2, subtly modify Dex contract with the previous level in a different way. You need to drain all balances of token 1 and 2 from Dex 2 contract to succeed in this level. You will still start with 10 tokens of 1 and token 2. The Dex contract still starts with 100 tokens of each. The things you'll want to consider. Here, how is the swap method modified, and could you use a custom contract in your attack? So if we look at this code, I have it here in VS Code. I suppose I could review everything once again, but this is literally going to be a copy and paste of the Dex video I just made. So I'm going to try to speed this one up with this review just to kind of get through it, because I've already explained it in Dex. So if this explanation is too fast, watch the previous video and I'll explain it slower there. So we'll quickly go through this. So the same as per usual, we have our compiler version 6.0. Remember, floating point's not good for production. We're importing a series of ERC20 contracts and safe math. This here is part of the reason why I was unable to solve Dex, which I'll dive into deeper later on. So we have our contract, which is Dex 2. Everything is the same here. So we have, we're basically importing safe math. We have a few state variables. So we have our token 1 and token 2 addresses, our constructor, which is going to implement these. So the person that deploys this contract, they're going to put in an address here. They're going to put an address here for both of those tokens. They're going to map those to these variables. This function swap, this is where all the magic happens. So the one thing you'll see the difference between this Dex contract and the other Dex contract is it's missing a require statement. And we can actually jump back and I'll show you specifically. Oops. Oh no, what did I do? There we go. So if we come back here and we look at the Dex contract, we'll see that here we go. Let's copy this swap and let's add it here for comparison. This is something I did in the last kind of when working through this. As you can see that identical, everything is identical except for this require statement. This require statement you can see is missing here. And this require statement is basically forcing us to ensure that anytime we swap tokens, those tokens have to be either token 1 or token 2. They cannot be any other token. So that means we're unable to mint additional tokens here and use those in our favor. But now that this has been removed, this require statement basically says that you have to you have to swap from this token to this token or from this token to this token is no longer relevant because you can see it's gone. So if that's the case, then let's remove this and keep explaining the code, and we will jump into specifically why that's a big deal. So we can see we're missing the require statement from the previous challenge. We have our other require statement that was there from last time, which basically states that you need to have enough to swap. So we're going to check the sender's balance, and if they don't have enough in their account, if it's not greater than or equal to the amount that's in their account, then they're going to send an error back saying they don't have enough to swap. We have a swap amount, which is going to basically get the amount that you want to swap from this token to this token for that amount. We have a series of ERC20 methods that we're going to use. So we're going to have a transfer from, which is basically going to transfer from the sender to the address they want to send it to, and then the amount they want to send. We have an approval saying that this address is allowed to swap this amount, and then we have a transfer from saying I want to transfer from the address to the sender that amount. So this is basically here saying I want to say we have A, which is us, and we have B. So we're going to say we want to swap from A to B, and then here we're going to say we want to swap from B to A, because whatever A is swapping to B, they're going to vice versa, right? Because you want to say A has token 1 and B has token 2. I want to swap 10 of my token 1 for 2. That means that B is going to have to give me 10 of 2 for the one that I've asked for, and that's kind of how those are mapped there. Below we have an add liquidity, which is just a helper method, and most of these are all helper methods. So this is add liquidity to the contract. So this is saying I want to add this type of token to the contract for this amount. We're actually going to use this for our attack. And in here, it's basically going to call on the ERC20 and say I want to transfer from the sender to the contract address that we're talking to here, this Dex. And then we're going to say we want to send a certain amount. Below that, we have a get swap amount, and this get swap amount is basically saying that I want to go from this address or from this token to this token address for this amount, and this is a public view returns, and it's going to return the specific amount that I want to swap, or the ratio is going to have a price, and you'll see that when I share it with you. But the formula here is something we discussed in the first Dex, which is basically saying this address, we're going to take the balance for the from token. And we're going to take this address and the balance from the to token, and we're going to multiply it by the amount that we want to trade. And when you do that, it gives you back a value of how much that the price is for that swap. And if we go down a bit further, we have approval. And this, again, is where the issues arise, both here and here. So we'll come to those in a second, but keep that in mind. Where we have our function, and it's an approve function. This approve function is saying that I'm going to allow this spender to use this amount. And it's going to call upon this contract down here, and it's going to then approve the spender for the amount, and the same for token 2, spender and amount. And balance of is just a helper function, so it's going to say, hey, this address, how much is in their account, basically, and it'll return back that balance from this ERC20 calling on that account for the balance of method. So this approval is basically approving itself, and when it approves itself, I think it makes it redundant. So when I tried to approve it in the Dex challenge where I failed, I couldn't approve it because it was approving itself. So we have to basically do a convoluted manual approval through Remix to allow ourselves to actually interact with the contract. I'm pretty sure this was not supposed to be a part of the challenge, but it is something that luckily I think JackDrummer helped me out with, which was pretty amazing. And one last thing here is, didn't mean to do that. This contract swappable token 2, we're going to use this to actually mint our own token. And this is a constructor that you'll see within ERC20. If you look at the specs for ERC20, you'll see that there's a specific type of minting function that takes these types of parameters, which is basically the name of the token you want to mint, the symbol for that token, and then also the total initial supply for that token. And then you'll get back basically the name and the symbol for that, so you can then interact with it further. And it's going to say, I want to mint this sender this initial supply. All right, that was a long explanation, but hopefully it was shorter than the last one. And we want to go to Dex 2, and we'll look at our notes. So I added this image because it kind of reminds me that we're basically going to create a malicious token that's worth nothing, and we're going to get a bunch of something from somebody that actually means that actually has value for it. And here's some of the solutions. So this one I've already discussed or like highlighted is this post. Another one is Naveen once again, and they've done a great job of really explaining and walking you through specifically what's happening. So I'll probably leverage some of their charts again to kind of walk you through what swaps are occurring and why we're able to kind of drain the funds. And this one here is another one that I came across, which is actually pretty straight to the point. They just say like, here's the challenge, here's how you solve it, and these are the swaps you're gonna make. I appreciated the directness, but without the explanation from the others, it would have been pretty difficult to interpret. It would take a little bit more time to grok. Now, what do I have here? All right, so I think I want to go back here, and I want to undo a bunch because I want to get something back in a second. There we go. So this bit of text and comments was actually a part of the YouTube video that I shared with you where I was getting assistance from this individual here, SuperJackdrummer. And in their explanation, you can see they explained what I just mentioned, is that here we're basically approving ourselves. And in the ERC20 implementation, that's really not, you know that by looking at the specs. So when you look at the ERC20 specs, you can see that they specifically mention here in that approval function that we're calling upon in ERC20, that the sender here is being called to be approved, but the sender for this call for the approval that's happening is actually going to be the address, not us, but it's going to be the contract address. So what's happening here is the contract address is approving itself to spend, and it's skipping us. So it's basically like feeding back into itself and completely ignoring us. So, we're sad, and we want to play the game, but the contract's like, no, you're not allowed to play the game because I'm going to keep approving myself. So the way we can get around that is something I'll explain right now. So we walked through the code, we've walked through some of this stuff. So what I'll do, actually before I do that, I'm going to walk you through this explanation here to specifically explain what we're swapping and how we're going to swap it out. So we'll walk through their explanation, then we'll implement it. So you can see here at the table, this is what we're initially going to start with, like we did with Dex. So we're the player, and we're going to start with 10-1 and 10 of token 2, and they'll start with 100 of token 1 and 100 of token 2. So we're actually going to mint either evil or malicious token. It doesn't really matter. We're going to mint a token, and we're going to mint a certain amount. Then we're going to allow the Dex to both exchange funds, as well as we're going to transfer some funds to them so they can exchange with us. So we'll initially transfer 100 to them, or we can transfer more if we'd like. Then we're going to transfer a certain amount to ourselves. So when we do this, we can actually swap back and forth, and we can give them evil token for token 1 and 2, eventually siphoning off all the funds from the Dex. Just for simplicity, they added each of these addresses to these variables, so you can easily put those inside of the further methods we're going to leverage later on. And then first you can see our initial swap here. So we're going to say we want to swap evil token for token 1, and we'll give you 100 evil token for 100 token 1. And if we go down here, you'll see basically that they're going to run a simple balance of to get the amount out, and you'll see that the output's going to be 0 for token 1 because we've just swapped everything out. And you can see that in this chart where we initially had 300 evil, but we've given them 100. So you can see they're 200, they've got 200 now, so we've given 100 evil, and we've asked for 100 token 1, so they've given that to us. So now we have 110 of token 1, and they have 0. And then we'll just do the same thing here. So we'll come down here, I'll run through the same process. We're going to say, I'll give you evil token. I'll give you 200 of evil token because I have currently 200 left. I'm going to give you 200 in a swap for 200 token 2. And we'll check the balance here once again. And you'll see that the contract address is token 2 value is 0, similar to what we looked at above. And then this is the final chart to kind of walk you through that. So we've basically said, I'll give you 200 token of evil for 100 token of this. So you'll see that they have 400. Now we've taken this into ours, so we have 110 and 110 of both tokens, and we've completely siphoned out everything they had there. So we've stolen all the money from the Dex, or at least all the money that's valuable and not the fake money we've created. And that's kind of how the process works. So before we can do that process, we have to go through the convoluted process of getting ourselves approved. So to do that, let's create some variables. Contract. And we'll do the same thing for token 2. All right, so now that we've done this, we're actually going to deploy these directly in Remix. So what I've done here is this is the guidance that I've gotten from this video from SuperJackdrummer. And basically all they did was import the ERC20 standard into Remix so they can manually approve those addresses. So you can see I've pulled it up here to deploy. And I'm actually going to skip over the deploy section here. I'm going to go straight to @address. So I'm going to deploy at a certain address, which is going to be the token address that's already deployed currently. I'm going to do the same thing for token 2. And I'll remove this and add this. And you can see when we expand these, we have all the methods and all the things accessible for an ERC20 contract for those tokens that are already deployed within the address that we're attacking currently. So what we need to do here is we need to do the manual approvals, because remember I told you it's feeding back into itself. And to approve it, what we need to do is we need to approve the address here, the contract address, say 500 for itself. And remember when I was trying to do the approval last time, this approval function, when I selected it, it would just keep spinning infinitely, and then it wouldn't allow me to do anything. But if we approve it manually, separately through Remix, it actually allows us to approve it. And we can see that it just succeeded. So we've approved token 1, and now we're going to do the same thing for token 2. And once we've done that, and that's approved, we're also going to come down to the allowance. And the spender is going to be the address that we're attacking, and then the owner is going to be us. And that's going to allow us to actually spend some of this money. So we've gone through that, and we've done the manual approval process. So I think we should be good to actually implement our contract. So this is going to be our attack contract. I'll delete this. And what was there is just an alternative method of doing this. So here we say, and I forgot to explain the attack contract, so we'll explain it now. So we have our compiler here. We have 8.0 as per usual. We're going to import ERC20. We're going to name our contract malicious token. We're going to basically inherit the ERC20 specifications. We have our constructor. Our constructor is empty. This is going to be a public ERC20 contract. What we're going to get returned is going to be the name of our token, which is malicious, and the name of our symbol, which is mal. And we're going to mint. So the sender is minting X amount of currency. So we're basically going to do a huge amount of supply, the initial supply, because we can, and it's fake. So it's all right to do massive amounts. So now we want to select our attack contract, and we'll deploy this. And when we deploy this, it'll come back and it should have a massive supply that we can interact with. All right, so it's approved. So if we check the total supply, you'll see that the amount that's there is just astronomical. You can see our symbol is mal, the name is malicious token, and the decimals are 18. And what we're going to need to do is we're going to need to approve our target address. We need to approve that they can actually spend this token. So we'll add a bunch in there. So I've given them, I think, the ability, I've approved the ability for them to spend up to 10 million malicious token. So once this is approved, then we're going to want to add liquidity to their contract so they actually have some malicious token inside of the contract. Awesome. So that was approved. So let's go back here, and what we're going to do now is we're going to add our malicious token to a variable so we can easily access it when we need to. Cool. And then we want to add liquidity to this contract. And to add liquidity, let's look at the function. So the token, we want to add the amount. So let's do our mal, and we'll add 100. So by this time, we should hopefully not get an error. Cool, we didn't. So a way to validate this is I think I have something saved already, which is something I pulled from the the blog post. So, okay, cool. So if I check the balance of, so I'm basically right here, I'm doing contract balance of the token I want to see for the player, and then I'm going to basically print this out to a string. And you can see my balance is ridiculously huge. And let's see what the target is. So the target has 100 because we've just added liquidity to the contract, so the Dex has 100 that we can exchange. And now we should be able to, theoretically, swap this out and take bunches of money. So here we want to do first, I'm going to basically say I want to do a swap method, and I want to swap my malicious token. Actually, I don't know if this is viewable. Let's do this so you can see it. So what I'm doing here is I'm going to call the swap method, and I want to say I want to swap my malicious token for token 1 for 100 of the amount. So I can basically empty the contracts 100 token 1. Groovy. We didn't get an error, which is always good. So I'm going to run this balance of again, but instead of running it on the malicious stuff, I'm going to run it on token 1, and you can see that token 1 is empty. So we've just taken all of the token 1 from the contract. So we're going to run this same exact thing, but we're going to do it for token 2. And if this doesn't error out, that means we know what we're doing. And while it's loading, I'm going to get the balance of prepared so we can quickly check to see if it's 0 or not. Okay, it's proved. And it's 50. Perfect. That means we did something wrong. But now it's 0. Well, whatever we did wrong, we fixed. Because after I realized that I did this wrong and we still had 50, I just ran this again. Since I have infinity of malicious token, I just kept on swapping until we got it down to 0. So you can see that I swapped 300 this time instead of 100 originally. And by doing this additional 300, you can see that now token 2 is down to 0. So if I make this console smaller so I can actually see the website, if we submit the instance, theoretically, we would have solved the challenge, and I would be a happy camper. Eureka. We did it. We did it, Internet. So you can see they give an explanation here of specifically what we're taking advantage of. And also there's a good blog post here that walks you through, specifically back in 2018, there was an implementation, there was an update to the ERC20 specifications that did not get updated in other tokens that were leveraging that implementation of ERC20. And when they did an upgrade, there was a list of 130 tokens that were actually affected by this this bug that could have led to what we just showed you in that challenge. So it's a good read. You should check it out. And that's it. Internet, I'm so pumped that we did this together and you helped me. So I'll see you on the next level, which is going to be called Puzzle Wallet, level 24.